Good night, PEP students. Welcome to another live PEP class. Tonight, being Monday night, we're going to be doing another performance task. And the title of this evening's performance task is Toilet Paper Rolls. Before we go into that, I'm going to play for you the schedule of live classes so that you'll be able to jot down the dates and the times and what sessions we do for each time. So we do 5 live PEP classes per week and 6 live CSEC classes per week. Here is the schedule. Hello CSEC math students, I know you are busy preparing for your math tests and your CSEC exams coming up. I have a very important question to ask you. Do you like my new hat? Thank you. Now another important question. Have you ever gotten a math problem wrong simply because of making one little mistake? I'm sure you have, as thousands of other students have. Now in this series, we're going to be looking at the common mistakes that students make with all the topics in CSEC Math. We're going to look at the common errors, demystify everything, make sure you watch every video in this series so that you can avoid making those mistakes. So stay tuned. Hello scholars, did you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake? Well, this is absolutely true, and we're going to be looking at the common errors that students make in the different topics in mathematics. If we know the errors beforehand, we can certainly avoid making them. Are you ready? Come on, take my hand. All right, guys. All right, so we're going to invite our scholars to join us on screen. All right, welcome Antoine, John, Madison, Amari. Welcome, students. Good evening. Are your mics working?
Good evening. Evening, Miss.
Oh, I thought your mics weren't working.
Miss, my mic is working very clear.
Oh, well, you didn't say good evening. That's why I thought it wasn't working, Anton.
Oh,
All right, so I'm going to share the screen. Okay. All right, so it's PEP performance task, and the topic is toilet paper rolls. All right, so persons in the chat are asking for the link, so here goes. All right. So in math class, the grade 6A students have been asked to use paper towel rolls and hand towel rolls. Sorry, that should be paper towel rolls and toilet paper rolls. All right, so let me fix that. So paper towel rolls and toilet paper rolls to make miniature models of gas cylinders. All right, in math class, the grade 6A students have been asked to use paper towel rolls and toilet paper rolls to make miniature models of gas cylinders. The diameter of both the toilet paper rolls and the paper towel rolls are 5 centimeters. Diameters are 5 centimeters. The length of the paper towel roll is 29 centimeters. The length of the toilet paper roll is 10 centimeters. So please jot those down. You're going to need that information later. Jot it down. The diameters of both the toilet paper rolls and the paper towel rolls are 5 centimeters, and the length of the paper towel roll is 29 centimeters. The length of the toilet paper roll is 10 centimeters. So I want you to jot those down. Jer, welcome. Scholars, I don't want you to pretend that you can't speak. I know you can speak. And when someone tells you good evening or tells you welcome, you have to say good evening or you have to say thank you. Don't you know that?
Yes, miss.
So why are you acting like you don't know that? And I'm not singling out Jer. I'm talking to all the scholars on the screen right now. I don't want this to happen again, scholars.
Yes, miss.
Okay. So let's go into it. So Antoine, please read question 1.
Okay, miss. 1A. What is the radius of each roll? B. What shape is each roll? And C. How much longer is the paper towel than the toilet paper roll? 1A. What is the radius of each roll? B. What shape is each roll? And C. How much longer is the paper towel roll than the toilet paper roll?
All right. So who wants to take 1A?
Miss, could I do it?
Go ahead, John.
Okay, Miss. So, Miss, since it said in slide 3, Miss, it said that the length of one of the two of the two rolls, Miss, it did say that the diameter is 5 centimeters, Miss. So we just have to find half of the diameter, and half of the diameter is 2.5 centimeters.
Okay, so you're saying that the radius for each of them is 2.5 centimeters. That is correct. I want to welcome all those in the chat, those joining us on YouTube, on Facebook, and wherever else you're joining us. Welcome. Please remember, you can leave your comments in the chat. You can leave your questions as well as your answers. When you're writing your answer, please put the number that you're responding to so that we'll know, because sometimes the chat lags behind. All right, so how about question 2? Who wants to do question 2 for me?
Mi-
Miss a cylinder.
Sorry, not question 2. I meant 1B. Sorry about that. Who wants to do 1B?
Cylinder.
mi-
Me.
Or
Go.
read over the question for me, Madison.
Okay, Miss. All of it?
1B. 1B, just the
Okay.
part that.
B. What shape is each roll? Miss a cylinder.
That's correct. And we were told that, right?
Yes, miss.
Yeah.
Right. So it's just a
Miss,
matter of remembering what you were told. We were told that they are cylinders. Yes, who had a question?
I was asking for C. C. How much longer is the paper towel than the toilet paper roll? Miss, I have 19 centimeters.
Okay, and how did you get 19 centimeters?
By subtracting 29 centimeters from 10 centimeters.
All right, so the length of um the hand the paper towel roll was 29 centimeters, and the length of the toilet paper roll was 10 centimeters. So we just subtract. All right, that is correct. Okay. Amari, please read question 2.
Wait. Okay, Miss. Each student was given a piece of rectangular foam 1.3 meters by 0.5 meters on the diagram. Label the dimensions of the foam in centimeters. Number 2. Each student was given a piece of rectangular foam 1.3 meters by 0.5 meters on the diagram label of dimensions.
On the
Label
diagram.
the dimensions of the foam in centimeters.
All right, so how would we label?
Miss would have to find out how many meters make us. Miss, how many centimeters make a meter, Miss?
All right, and how much is that?
Miss 100 centimeters make a meter.
All right, so we're asked, so first let's do the conversion. So for the 1.3 meters, that would be how many centimeters?
Miss, that would be 130 centimeters, Miss.
All right. And for the 0.5 meters,
Miss, would that be 50 meters?
all right, so we're multiplying the meters by 100 to get centimeters. So we're asked to label So where would we put these on the diagram? Where would I
Miss,
put the 130 centimeters?
Miss, I can't really see the bottom part, but the 130 centimeters would go at the top of the diagram.
So the length, I need a brighter color. Okay, the length is 130. So we'd put that here, 130 centimeters, and the width is 50 centimeters, so that would go here. Or we could write it along there. All right. So let's go on to the next question. Okay, so Madison, question 3, please.
Okay, Miss. Number 3. If the toilet paper rolls were arranged upright in rows and columns across the face of the foam, how many full rolls would hold along one length? Explain how you got your answer. Number 3. If the toilet paper rolls were arranged upright in rows and columns across the face of the foam, how many full rolls would hold along one length? Explain how you got your answer.
All right, who wants to take this one?
Miss,
Mm,
Miss, I'm not sure on how to approach it, but this is my approach.
okay.
So should we so since the top part of the rectangle is 1 centimeters, should we divide since there are 5 centimeters is the diameter of
Mm-hmm.
the toilet paper rolls, Miss?
Mm-hmm.
Should we divide 130 centimeters by 5?
Yes, we
Yes,
would, Antoine.
that's what I did.
Right. So Madison got that. Madison posted her answer in the chat. Yes, Antoine. And what would you get if you did that?
Miss, I'm working it out.
All right. So very good, Antoine and Madison. So remember the length. We had just worked out that the length in centimeters along one edge was 130 centimeters, and since the diameter, so Antoine is saying, since the diameter of each toilet paper roll is 5 centimeters, then in order to see how many can hold along the length, we would divide. Did you get your answer, Antoine?
Yes, Miss, I got 26.
Okay, that's correct. All right, Jared, question 4, please.
Okay, Miss. 4. How many rolls could fit across the entire face of the foam? 4. How many rolls could fit across the entire face of the foam?
All right, so what we're saying for this one, the entire face of the foam.
May I say how we would approach it?
Yes, Madison, go ahead.
We'd multiply 130 by 50 and then divide it by 5.
Divide it by 5. Would you
Yes,
divide it
miss.
by 5? Why would you divide it by 5?
It's because the diameter of the rolls are 5 centimeters.
But it's not the diameter you need to think about now in terms of, or if you're multiplying, if your approach is to multiply the 130 by 50, now you're getting into area, right? So
Yes,
we
miss.
wouldn't divide area by diameter. We wouldn't divide the area of the foam by the diameter of the roll to see how many it can hold. We'd have to divide the area of the foam by the area of the roll, the area of the roll. If that's the approach, that's not the only approach we can take. But if you're going to approach it that way, then that's what you would need to do. See what area each roll would take up, and then divide the area of the foam by the area of each roll. But there's another way we could do it as well. Can you think of another way we can do it? And if you want to do it that first way, then go ahead and tell me what you get for that. So
Okay, miss.
question 4 is asking, Okay, so question 4 wants how many would fit across the entire face. So do you remember how we worked out how many could fit along the length? Remember what Antoine and Madison did to work
Miss, we
out
got
how many?
26.
So could we find out how many would fit along the width and then multiply those? Could that be an approach we could take? If we know how many could fit along the length and how many could fit along the width,
Yes,
then we could do row by column, right? So how many would fit along the width?
Miss 4.
How 4?
Miss, because looking at the diagram, you can see that the 26 that go over it can line up 4 times,
No,
4
don't
rows.
judge it by the diagram. The diagram is not done to scale.
Oh, okay.
Judge it by the measurements that you're given. So we were told the width, weren't we?
Yes, miss.
We just worked out how many centimeters is the width?
50.
50. So how many of how many of those rows could fit across the width? Remember, the diameter is how much?
5. Miss, so would it be 10?
So 10 can fit along the width and
Yes.
26 can fit along the length. So how many can fit along the entire face?
26.
260.
That is correct. 260.
260. Miss.
Yes, 260 can fit. All right, let's continue. Antoine, question 5.
Yes, miss. Question 5. If rows were placed across the foam so that no more full rows could fit, approximately how much empty space would remain on the foam? Number 5. If rows were placed across the foam so that no more full rows would fit, approximately how much empty space would remain on the foam?
Okay, so how do we approach that? How do we approach that?
This I'm not sure.
All right, how about you guys in the chat? Let me hear your answers.
Miss, I'm
If
not sure.
we think about it some more, if we put toilet paper rolls across the face of the foam so that no more full toilet paper rolls can fit, how much empty space would remain on the foam? Welcome, Danicia. Welcome, Ashlyn. Come on, guys, think about it. So we have been working so far. We said that 260 full rolls can fit. I remember oftentimes when you're doing questions like these, performance tasks or worded problems, oftentimes the answer that you get in previous sections, you're going to need them for the sections to follow. So always be jotting down the important information and always be jotting down the answers that you get for the previous sections, because you might very well need it for the questions that follow. So each time we work out the answers, we should be jotting them down. In your actual performance task, of course, you would have it on your paper to look back at. For now, we're working them together on the screen, but you should be jotting down your answers. Danny says saying 80, but 80 what? And how did you get 80? Which question are you answering? Danny says. All right, so does anybody have any ideas? We said 260 of the toilet paper rolls can hold. So the question says approximately how much empty space would remain on the foam when we place those 260 toilet paper rolls to cover as much as possible. No more full toilet paper rolls can hold. All right, so you got a whole number for what, Madison? Oh, you're saying no space is left? What about the space between the rolls?
Oh.
There is space left. No full toilet paper roll can fit, but we have space between the rolls. All right, so how I want you to approach this. We know the area of do we know the area of the foam? And if we don't know it, can we find it? What would be the area of the foam?
6,500 centimeters.
And how did we get that?
We multiplied 130 by 50.
Okay, so the 130 centimeters, which was the length of the foam, times the 50 centimeters, which was the width, and that gave us 6,500 centimeters square. Do we know the area of the bottom of the toilet paper roll? The area that the bottom would take up on the foam? Can we find it? Can we find the space that each toilet paper roll would take up on the face of the foam? Can we? Yes or no?
Miss, since there's
Yes,
since there's some rolls on the length of the foam.
No, don't look at the diagram, John. The diagram, the picture is to give you an idea of how the rolls will be stacked, but it's not using the same scale as the dimensions we have been given.
Okay.
So work with the actual measurements that you've been given in the problem. Use the picture just as a representation of how you would stack the rolls. Can we find the area of how much each roll would take up on the foam? What information do we need to find the area? The space that the toilet paper roll takes up is a circular space. Is it? Yes or no?
Yes, miss.
How do we find the area of a circle? Area of a circle is pi times the radius squared. Pi times the radius times the radius. What's the radius of each toilet paper roll?
Miss 2.5.
2.5.
So can you work out for me 2.5 times 2.5 times 3.14? Or if you want to work it as a fraction, 2.5 times 2.5 times 22/7. Whichever way you want to work.
Miss, it's 19.62, Miss.
Okay, 19.62. But they want full rolls, so we have to round down. The 19.62 would
Miss,
so it would be 19, and then piece of a roll would stick off. So we have to work with the 19 full rolls. You get that?
yes,
So
Miss.
then, since each roll would take up roughly 19 centimeters squared, and there are 260 rolls, can you work out the area that those rolls would take up for me? So the 19
Miss,
times 260.
okay, Miss, that would be 4,940.
Are you using a calculator, John?
Oh, yes, Miss.
Yes or
Yeah, I
no?
can't work. Yes, Miss.
Yes.
Miss,
Are you aware that we don't use calculators for PEP?
yes, Miss.
Okay. So don't. So 260 times 19. Okay, so that's 4,940. So what's the final step we need to take now? We worked out how much area the 260 rolls would take up. The question says approximately how much empty space would remain on the foam.
Miss, what will we subtract?
Subtract what, Antoine?
6,500 from 4,940.
Are you sure that's the way we would do it? Take the 6,000 something from the 4,000 something.
Out.
Did you
No,
say it the right way, Antoine?
no. The
Say it the right way.
4,940 from 6,500.
Please do that and tell me what you get.
Yes, Miss.
Hello, Pro John from Trinidad. Welcome. Was it Trini or Barbados? I'm trying to remember. These are our Caribbean brethren joining us. Remind me, Pro John, if you're from Trinidad or Barbados. All right, so the rest of you can work it as well. So we're saying the 6,500, which was the area of the foam,
Miss,
minus the 4,940, which is the area of the 260 toilet paper rolls. Yes, John?
Miss would answer be 1,560 meters.
Centimeters squared.
1,000. Yes.
Centimeters squared. All right, that is
Yes,
correct.
Miss.
Okay, so Pro John is reminding us he's from Trinidad. Welcome to our Trinidad brothers and sisters, Trinidadian brothers and sisters. Madison, are you back? Madison not back. And I think Jer left. Jer had to go. John, could you read question 6, please? Let me see who else I can
Miss, for
add.
some reason I couldn't unmute. Can you hear me?
All right, go ahead, Madison. Read number 6, please.
Miss, I was never gone, by the way.
Okay.
Number 6. Some rolls are then placed inside an open tin can of radius 9 centimeters. What is the area of the base of the tin can? Some rolls are then placed inside an open tin can of radius 9 centimeters. What is the area of the base of the tin can?
Okay, how do we approach this? How do we approach this? What is the area of the base of the tin
Miss,
can? Madison?
would we times the radius by 2?
To find the area of the base of the tin can. What shape is the base of the tin can?
A circle.
So how do we find the area of a circle?
Which I don't remember.
Does anyone remember how to find the area of a circle? Shelicia, welcome.
Pi times.
Does anyone remember how to find the area of a circle? No one? We just did though, didn't we?
Miss?
When we were finding the area of the base of the toilet paper roll, we said pi times the radius squared.
Miss? Yes, miss. That's what I was going to say. Pi times radius.
Okay, so what would be the area of the base? So the radius is 9 centimeters. So it will be 9 times 9, because it's the radius squared, times pi. You can work it as 22/7 or 3.14. So can I get an answer for that one?
Miss, I don't really understand how to find pi, the pi
Pi
of the.
is 3.14.
Oh,
And the radius is 9. So it's the radius squared, the radius times the radius, 9 times 9, and then you multiply that by 3.14.
Miss 247 centimeters square.
247.
Sorry, 246.
So 81
miss, the
22/7. That's
miss,
not what I got. Go ahead, Antoine.
my answer is 254.34.
Point three.
34
Right, that is what I got. 254.34. What's the unit?
centimeters,
It's area, so it wouldn't be centimeters.
not centimeters.
What's the unit for area? What's the unit for area, scholars? With
Miss
centimeters?
unit squared or centimeters squared in the
Centimeters
States.
squared. Okay. All right, so we passed the halfway mark and we have 2 scholars waiting. So I'm going to ask us, we're going to have a switch. All right, so I'm going to ask Antoine to wait backstage and Madison to wait backstage. You can still post your answers.
Yes.
Okay, so you can still post your answers. And I'm going to welcome Jaden and Lejonde. Okay, welcome Jaden, welcome Lejonde.
Hi, Miss.
Good evening.
Good evening.
Sitting, miss.
Okay, Shalicia, I'm going to ask you to read question 7. Go ahead, please. All right. So they're talking about full toilet paper rolls. So how would we approach this question? How many of the toilet paper rolls can hold inside the can?
Miss, can I get a minute, please?
Who is asking for a minute? Antoine?
Me, Miss Legende.
Legende? Okay. How do we approach this, scholars? How do we work out how many of the toilet paper rolls can hold inside the tin? Projan is asking me if I know these people. Are you referring to my scholars as these people? Some of the scholars who appear on screen, some of them are my actual students. Some of them I have never met. They are just scholars who I post the link in the chat and they have decided to join us. But most of them are my actual students. All right. So come on, guys. What approach did we take when we wanted to know how many of the toilet paper rolls could fit on the foam? What approach did we take that time? Do you remember what we did for that? When we wanted to find out how many of the toilet paper rolls could hold on the foam, do you remember what we did? Yes? No? You weren't listening? Weren't paying attention? We found the area of the toilet paper roll and the area of the foam, and we divided the area of the foam by the area of the toilet paper roll. So we already have the information about the toilet paper roll from earlier questions, and the question previous to this one, we found the area of the tin, the base of the tin. So we already have the information that we need. So we just need to divide now the area of the tin, the base of the tin, by the area of the toilet paper roll. Did you jot down that information? Remember, I told you we need to jot down the information as we go along, the answers that we get for each one, because very likely you're going to need the answers to work out questions that are coming up. So they're talking about full rolls. So we can even do some approximation. We can say, okay, so for question 5, we said the area, we rounded it to 19, since we didn't want any toilet paper rolls sticking off the edge, right? And we just worked out the area of the tin can, the base, as 254.34. So please divide that by 19 and tell me what you get.
Miss, repeat the figure one more time.
254.34 centimeters squared was the area of the base of the tin can. And the area of the toilet paper roll is 19.625. And the question had asked approximately, so we rounded down to 19. So you can round now, or you can divide it by the 19.625 and then round it. When you get the answer, you can round that answer, because we don't want any toilet paper rolls sticking off, or we don't want any squashing up in the corner of the can, right? We want full toilet paper rolls. So when you divide the 254.34 by the 19, did you tell me an answer, someone? All right, so in the interest of time, it would be approximately 12 rolls. Okay, so I just see Antoine giving me his answer, 12.96. So we're rounding it down to 12 rolls. We want full toilet paper rolls that can fit neatly inside the can, right? None squashing or having to stick out anywhere. So we're rounding it down as opposed to rounding up, rounding it down to 12. All right, Jaden, can you read question 8, please?
Okay, miss. Number 8. Each toilet paper roll represents a miniature model of a gasoline cylinder. Which of the following can hold 450 liters of gas? How many real cylinders will hold 9,000 liters of gas? Number 8. Each toilet paper roll represents a miniature model of a gasoline cylinder, each of which can hold 450 liters of gas. How many of the real cylinders would hold 9,000 liters of gas?
All right. So what say you? How do we approach this one? So these toilet paper rolls are miniature models. They are representing real life gasoline cylinders. And the real cylinder, each of them can hold 450 liters of gas. How many real cylinders would hold 9,000 liters of gas?
Miss, would you see which number 450 times that number would equal 9,000?
And how do we see which number? When you say we can see which number, what do you mean? How do we see which number? How do we go about that? When you want to see how many of one thing we can get out of another thing, what's the operation that we do?
Miss, the operation would be to divide. Miss, you divide
The
that.
operation, that's correct, John. The operation would be to divide. So please divide and tell me what
Miss
your
already
answer
divided.
is.
Miss already divided.
What's the answer?
Miss 20 liters. Oh, 20, miss. 20. 20 of
20,
real
20
cylinder.
cylinders.
20 cylinders of gas.
Okay, and I'm seeing Cash Mark in the chat is saying 20. Also, Ashlyn is saying 20. And Overcomer Jody Ann is saying divide. All right, so several scholars were on point with that. All right, so question 9. Madison, please read question 9.
Okay, miss. Question 9. If 4 rolls are placed side by side to touch, what would be the full length on the ground that they take up? 9. If 4 rolls are placed side by side to touch, what would be the full length on the ground that they take up?
Okay, this one is easy as pie, right? What would be the length? If we had the 4 rolls lined up, similar to how they are in the pic, but there's no space between them. They are touching each other. If we took a ruler and
Miss,
measured from the end of the first one to the end of the fourth, what would be the distance on the ruler?
Miss, 20
20
centimeters.
what? Why? How?
Because the diameter is 5 centimeters for each of them. And
Therefore,
there's 4 rows. So 4 times 5 is 20.
that is correct, Madison. Shelicia, number 10. Shelicia. All right, what's the total height, or if you want to say the total length of all the rows seen here? I thought I would have an answer within a split second.
Miss, 1.26 meters.
And how did you get 1.26 meters, madam?
I multiplied 29 by 4 since there's 4 of the long rows there. And then there's a small row, which would be 10 centimeters. So 29 times 4 is 116 or 106. And you add the 10, which would
116.
116, sorry. And then you'd add 10, which would give you 126. And then you'd divide that by 10, I think, and then
100 by 100.
100 by
Because we're
100,
changing
and
centimeters to meters.
yes, and then you
Okay.
divide it by 100 and you get 1.26.
Yes, that is correct. Jaden, question 11, please.
Okay, miss. If you place two small rows vertically to stand on top of a large roll, what would be the full length in meters? If you place two small rolls vertically to stand on top of a large roll, what would be the full length in meters?
Full height.
Or
Full height in meters.
full height in
All right, so what would
Miss,
be the full height? Hold on, Madison. What would be the full height? Let me hear from some other scholars. So Madison has posted her answer in the chat. I want to hear from others. So we're stacking the rows. We're putting one of the large roll and we're putting 2 on top. So we have 1 large roll and we're putting 2 small ones on top of that. So what's the total height? So Madison has put her split second answer, but I want others to give me their answers as well. Ashin is saying 1.26. I think that's the answer for number 10. The chat does lag behind, so maybe she had posted that. So remember to put the question that you're answering. All right, so time is going, so I'm going to allow Madison to give me her answer and explain how she got it. Go ahead, Madison. Not hearing you.
Oh, sorry, miss, I was muted. So the long roll that they're placing the 2 small rolls on is 29 meters. And then there's 2
Is it
small rolls.
29 meters?
Sorry, centimeters.
Okay.
And then the 2 small rolls that they're putting on it is 10 meters each. So 10 times 2 is 20. And then 29 plus 20 is 49. So we are dividing 49 by 100, which would give you 0.49.
0.49 what?
Meters.
Correct. All right, 3 questions to go. Shalicia, question 12. Shalicia. Go ahead, please. All right, so what do we do for this one? How many times taller? What do we do for this one, scholars? How many times taller is the
May I
paper towel
answer?
roll? Go ahead, Madison.
We divide 29 by 10, and I got 2.9.
All right, that's correct. So the paper towel roll is 29 centimeters. The toilet paper roll is 10 centimeters. So to find how many times taller, we divide and we get 2.9 times. All right, John, I'm going to ask you to read question 13, and then we have 1 question after that.
Okay, miss. Number 13. The students will use beads. The student
Sorry.
will use beads.
Go ahead.
Okay, miss. The students will use beads to represent the gas in the cylinder. How many centimeters cubed of gas would hold in 2 of the miniature cylinders? Number 13. The students will use beads to represent the gas in the cylinders. How much centimeter cube of gas will hold in 2 of the miniature cylinders?
Okay. So remember, we had said these toilet paper rolls represent actual cylinders of gasoline. All right. So how many of the miniature cylinders? How many of the toilet paper rolls? Well, it's two toilet paper rolls. How much centimeter cube of gas? Using beads to represent the gas, right? So if it's full to the brim with the beads, How much centimeter cube of that gas would that be? Remember, centimeter cube, even though the centimeter is a length measurement, centimeter cube can actually be used as a capacity measurement as well. So how would we work that? How much centimeter cube would two miniature cylinders have? Madison saying 100 centimeters square, 100 centimeters cubed. How did you come by that?
This, I think my answer is wrong, but the students use beads to represent the cylinders, and the length of one of the cylinders is 10, and Miss, I forgot how to talk for a second.
So
Hold on.
centimeter cube is a capacity measurement, which is volume. It's a cylinder, so volume is area times height. We already worked out the area of this cylinder. The base of the toilet paper roll, we worked that out. What was that? We had worked it out before. To find the volume or the capacity of the cylinder, we need the area of the base times the height. We already worked out the area of the base of the toilet paper roll. Do you remember what that was? That was 19.625 centimeters squared. And the height of the cylinder is 10 because the toilet paper roll is 10 centimeters. And it's two of them. So it will be 19.625 times 10 times 2. Can someone work that out for me? Not 5 times 10 times 2. The area of the toilet paper roll,
Miss, give
19.625. Yes,
Miss
John?
19. Miss 19 point what, Miss?
19.625 times 10
Okay.
times 2, since it's two cylinders.
Okay. He said 19.56, right, Miss?
19.625
Okay, Miss.
times 10 times 2. So you can just say 19.625 times 20 then.
Miss 382.40 or 382.40.
I think you made a little error there with your calculation.
Okay, Miss.
One of your digits is off.
Miss 382.50.
392.5 centimeters cubed. 392.5 centimeters cubed. Final question, Amari. Question 14.
Question 14. The ratio of toilet paper rolls to paper towel rolls was 5 2. 5 2. 5
5 to 2.
2. 5 2. If there were 16 hand towel rolls, how many of both rolls were there in all? Question 14. The ratio of toilet paper rolls to paper towel rolls was 5 to 2. If there were 16 hand towel rolls,
So this should be paper towels. 16 paper towel rolls.
paper towel roll. How many of both rolls were there in all?
All right, so this is the last question. How do we approach this one? It's a ratio question. This is a ratio question. The ratio of toilet paper rolls to paper towel rolls was 5:2. If there were 16 paper towel rolls, how many of both rolls were there in all? Anyone wants to get the ball rolling? This is
It's
ratio.
112.
So you need to explain to me, Madison.
Okay, Miss. So since the ratio is 5:2, I added 5 plus 2, and I got 7. And then I multiplied 16 by 7, and I got 112.
You multiplied 16 by 7.
Yes, Miss.
But why would you multiply 16 by 7? 16 is not the unit value of the ratio. 16 is what the paper towel rolls. 16 goes with the paper towel rolls. 16 is not the unit value for the ratio. The first thing we need to do is to find the unit value for the ratio. So we can do that by working with the paper towel roll. Since we are told that there are 16 paper towel rolls and we are told that the value of the paper towel in terms of the ratio is 2. So if we divide the 16 by 2, we'll get the unit value for the ratio. And then we can multiply that by the 7, which is the total value for the ratio. So 16 paper towel rolls and the ratio for the paper towel is 2. So we divide 16 by 2 and we're going to get 8. That's the unit value of the ratio. The total ratio is 5 plus 2, which is 7. And if we multiply that by the 8, we get 56. So in all, there were 56 rolls. If we wanted to find the toilet paper roll, we'd multiply the 5 by the 8. So it would be 40 toilet paper rolls and 16 paper towel rolls. So that's 56 in all. And we have come to the end of our performance task. I want to thank you, my beloved scholars, for being with me as usual and working out your problems and seeing, where gauging yourself in terms of your problem solving skills and your ability to pick out important information and work with what you know to find out what you don't know. Tomorrow we continue our ability test. We were on work paper 3. So we're going to complete work paper 3 tomorrow for the ability test. So be there or be square. Until tomorrow, I'll see you. I'm going to play now the schedule of live classes to remind us when we have what. All right, so good night.
Bye, Miss.
Good night. Enjoy your night. math students, I know you are busy preparing for your math tests and your CSEC exams coming up. I have a very important question to ask you. Do you like my new hat? Thank you. Now, another important question. Have you ever gotten a math problem wrong simply because of making one little mistake? I'm sure you have, as thousands of other students have. Now, in this series, we're going to be looking at the common mistakes that students make with all the topics in CSEC Math. We're going to look at the common errors, demystify everything. Make sure you watch every video in this series so that you can avoid making those mistakes. So stay tuned. Hello scholars. Did you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake? Well, this is absolutely true, and we're going to be looking at the common errors that students make in the different topics in mathematics. If we know the errors beforehand, we can certainly avoid making them. Are you ready? Come on, take my hand.